Hello Rajiv, we will wait for 5 more minutes. We will see if anyone joins, then we will start. Okay. Yes, Kokila. Okay, so we will start now. Okay, so in la previous week lectures, we have learned about the composting processes, different types of composting processes, and different factors which were going to affect that composting process. And we mainly talk about the windrow type and aeration type composting processes that is done generally manually and in fields. Okay, so in this week lectures we will talk about the composting processes done with the help of some mechanical operations or in vessel composting system, rotary drum composting system. Kokila, can you mute your mic?
ऑनलाइन क्लास बोलता नहीं फोन चाहिए
Okay, so coming to the type of mechanically operated composting systems. So There are different types of reactors which generally used for composting processes, like horizontal drum type reactor system, vertical silo system, and open tank system. So these systems are automated and provided with some agitation, provided with some mechanical systems which can easily agitate the uh, waste material during the composting process for the proper aeration. Okay, because we need proper aeration during the composting processes. Okay, so there are some diagrams for these horizontal or plug flow type vertical systems. As we can see in horizontal reactor, we are providing the material from here. Okay, and we are getting the composted material from the other end. Okay, and in between these we are providing the air distribution system in these horizontal drums. Same in the plug flow vertical type reactor. In this type of reactor we are going with the counter current processes. Okay, from lower side we are providing the air, and from upper side the material is coming to downward side. And in this type of the major advantage of these vertical silos are, like we can go for continuous composting process. Okay, so what we are going to do, we are providing the material from here, and from here we are providing the air. So this is a mechanism for removing the compost material out from outside the silo. So we can take out compost material every day. Okay, and we are providing the same amount of waste material from the upper side every day. Okay, so that can be run as a continuous composting process. Okay, then there are silos or tower type reactors in which we can add the material on daily basis, and we can remove the compost material from the downward side on a daily basis. Okay, in vessel drum composting system, we are providing some system for air blowing, and we are rotating that drum continuously during the composting process. So your material, whatever waste material we are going to provide, that is going to mix properly, and due to that mixing, we are providing the aeration inside that material. Okay, for the proper composting process. Then there are some specifications for these rotatory drum type systems. That can be a drum of about size of 3 to 4 meters in dia, and it can be long up to 35 to 40 meters long, for a daily capacity of around 50 tons per day. Okay, and it can provide a residence time for that waste material up to 3 days. Okay, so after this 3 days, we will provide a residence time of 3 days for the waste material, and after 3 days, further decomposition of this compost material will be done with the help of windrows or aerated static pile systems. Okay, so we are doing the partial composting in the rotatory drum mechanism, and then partial decomposition will happen in windrow or aerated static pile type system. Okay, then there are some images of different types of rotary drum type composters, and here is a centralized composting plant in Boregaon dump site, Guwahati, which are using this rotary drum type composting system for converting the municipal waste into the compost material. Then there are some more images. Okay, and then coming to the advantage of these rotary drum type composters. Okay, there are some advantages uh, as compared to the aerated or static pile type system. Okay, so the composting time will be short. Okay, in aerated or static pile type system, it was taking around 14 to 50 days for the entire for the composting of the waste material. While in the rotary drum system, we can go for a time period of around 3 to 4 days normally, and your compost material will be ready. However, if you want some more decomposition in that compost system, if you feel that more decomposition is required, so after 3 or 4 days, we can go for aerated or static pile system to provide the further decomposition during the decomposition process. Okay, and then in the rotary drum composter, temperature can reach up to 65 to 70 degrees Celsius, which is the ideal temperature for composting process. But we don't want the temperature to increase beyond 70 degrees Celsius, because if the temperature is going beyond 70 degrees Celsius, the microorganism will begin to die. And due to, if the microorganisms are going to die, so proper composting will not happen. Okay, then it needs less space requirement, odor problem will not be there, and it is easy in operation, and it yield uniform marketable compost, because we are providing we are continuously providing the aeration, and like we can say, we are mixing the material continuously during the composting process. Okay, so it will provide us uniform yield for marketable compost material, and it is environment friendly, and no leaching or spillage will happen. What will happen during the aeration or static pile system, if there is going to be rain? Okay, so during the rain process, what will happen? The water will interact with that compost material, and it will react with the that waste material, and there will be some leaching or spillage due to that due to that rainwater. Okay, but in rotary drum system, that will not happen, because we are not it will not be able to come in contact with any outside water or moisture. Okay, and there are some limitations also during for these rotary drum systems, like we need a high capital cost around 1.5 lakhs or 2 lakhs uh, minimum for a pilot plant scale rotary drum system also. Okay, and then there will be some power requirement also during that aeration or static pile. We generally don't need any power requirement during the operations. Then with the these rotary drum reactors can be made at pilot scale also, as we can see in the figure. So, and there has been some successful trials in IIT Guwahati by waste management research groups on these rotary drum systems for composting of municipal different types of municipal solid waste. So there are some images. Then they have provided some results for. Okay, so in the rotary drum composting process, the temperature pattern will be like this. There will be some active stabilization time period. Okay, that will be known as thermophilic, and temperature will uh, go from 70 degrees Celsius to downward up to 40 or 50 degrees Celsius during the active stabilization period. Then there will be 2-3 days of cooling period from 50 degrees Celsius to 40 degrees Celsius, and then there will be maturation period for 7 to 15 days. So for maturation period, we can provide that maturation period via aeration system or static pile system also. We don't have to do that maturation inside the rotary drum composter system only. Okay, after that 5 to 6 days of active stabilization and cooling period, we can go for the aeration or static pile process for the maturation time period of 7 to 15 days. Okay, then coming to the second lecture of the week. Okay, so we have created some compost material with the help of the municipal solid waste via different processes, like rotary drum composter, or maybe we can go for static or aeration pile type system. But before that compost hit the market, okay, we have to check the quality of the compost material before going to the marketing of that compost material, or before using that compost material. Okay, that has to be checked. So compost quality can be evaluated through laboratory analysis. There are some laboratory analysis process. There are some defined methods for these processes, some Indian standards, or some we can say some standards created by the fertilizer industries. Okay, so with the help of those standards, we can check the quality of these compost materials. Okay, so the major qualities of these compost materials are they have to be well matured. We have to give them a time period of around 7 to 15 days for the proper maturity. Then no foreign matter should be there. Okay. After composting process, what we can do, we can do a sieving operation. Okay, so if any debris or any inert material is coming in that compost material, that will be going to be removed during that sieving operation. Okay, then low amount of trace elements like iron, silicon, some elements will be there, some heavy metals will be there, but that has to be on very low amount like fluoride or we can say bromine content, and some hazardous content can be also there, but that level has to be on the ppb or ppm level only. Okay, then good physical and chemical characteristics should be there. It contains a proper amount of humic substances, no pathogenic organisms should be there, and no organic contaminants should be remain there for the proper composting quality. Then there are some important parameters which needs to be analyzed during the composting process. There are three different parameters. First is physical parameter, then chemical and biological parameters. Generally, physical parameters contains the bulk density testing, then porosity, void ratio, and water holding capacity of that compost material. Okay, then coming to the chemical parameters, we have to check the pH of that compost material, because what will happen if the pH of the compost material is not in between 5 to 8. Okay, so what will happen if we are going with very high acidic pH value in the composting process, or very high basic value in the compost. Okay, so that will affect the soil content. Okay, very high acidity or very high basicity is going to affect the soil content. So we need a optimum pH value in between around 5 to 7.5 or 8, something like that. That has to be neutral. Okay, then EC, electrochemical conditions, then TKN and ammonia content should be checked. Total and available phosphor contents, then micronutrients check should be there like sodium, calcium, magnesium, and Fe. That amount has to be in the optimum proportion in that compost material. If the amount is not in optimum proportion, that is going to affect the health of the soil. Okay, then there are some biological parameters which need to be checked after the composting process like SBOD, COD, carbon oxygen content, then caliform, total and fissile stability, that is defined as O2 uptake rate and CO2 evaluation rate. Then coming to the physical effect of composting on soil structure, those physical parameters which are going to affect the soil structure. A compost particle is lighter and finer than a soil particle. Okay, so why we need the finer particles than soil? So that it can be easily mixed up with the soil content. Okay, then on mixing with the soil, the compost particle decreases the bulk density as mass per unit volume reduces owing to lighter compost particle. Okay, so it is understood if we are going to mix a higher density powder with a lower density powder. Okay, so the total density is going to be on the middle size. Okay, so during the mixing process, we need a lower dense for compost material. We need a lower density material. Okay, then compost particle being finer, that will increase the absorption area, which in turn increases the water holding capacity of the soil and void ratio or porosity, etc. Because if we are going to create a finer size during the composting process, okay, so more finer size will create the more surface area to volume ratio. Okay, the volume will be on the lower side and surface area will be on the higher side, and that will create the more porosity inside that compost material, and due to that more capacity, the capillary voids will be in the larger amount, capillary voids, amount of capillary voids will be in the larger amount. Okay, and that capillary voids are going to hold the water, and it will increase the water holding total water holding capacity of the soil material. Okay, then coming to the chemical parameters, first chemical parameter is pH value. Okay, so precipitation of essential nutrients out of solution may occur at higher pH. Okay, like if we are going for the basic pH value of the compost material, then what will happen? If we are going to mix it with the soil, so the pH of the soil is going to get increased, and due to that increase, the essential nutrients will get precipitated from the solution. Okay, a pH between 5.5 and 8.0 is optimal for compost microorganisms, and 6.0 or 7.5, in between 6.0 and 7.5 for bacteria, and 5.5 to 8 for fungus. So we need a pH value in between around 5.5 to 8 will be the ideal condition for a compost material. Okay, then that is stoichiometry. Then electrical conductivity. The electrical conductivity refers to mineral salts or amount of mineral ions in the solution of compost and water, and that has to be on the optimum size of around 2 to 3 ds per micron. Okay, concentration of final EC also depends upon the conductivity of soil. So what will happen if we are going to see this EC? So as we are going to increase the time of composting, like why we require that maturation period, during that maturation period we are going to get the optimum amount that electrical conductivity. Okay, because phototoxicity of plants is going to be higher due to the volatilization of the NH4 contents and precipitation of mineral ions during this maturation time period. Okay, so electrical conductivity will be will be around 2 to 3 ds per m. Then organic matter content, that has to be, organic matter are the sources of nitrogen and carbon to the microorganism, and that has to be on the optimum side, and that is also going to be stabilized during the maturation time period. So for increasing, for getting the optimum electrical conductivity and organic matter, we need a optimum time period of maturation after the composting process. So then coming to the nitrogen content, we need a proper carbon to nitrogen ratio in the final compost material. Then coming to stability, CO2 evaluation and oxygen uptake rate. During various metabolic activities like respiration, carbon is used as the source of energy during composting process, which leads to decline in organic carbon and release of CO2. Okay, so during the respiration process, what will happen? Because some microorganisms will be there, and they will do the respiratory actions for their living. And due to that respiratory action, what will happen? The oxygen content is going to react with the carbon content present in the compost material, and that will result in the decline of organic carbon content, because that organic carbon content is going to react with oxygen and going to convert into the CO2 gas. So that content has to be optimized stability, for stability. Then coming to the metal parts in compost. Okay, that has to be in trace amount. There are some limitations regarding different metal contents. There are some, like we can say, there are some optimum values. So for a proper compost material, though these values should not go higher than these prescribed limits for different elements in the compost material. So what are the problems which are going to be created due to these metal contents in this compost materials? Okay, so some metal contents like iron, if iron amount of iron is on the higher side in the compost material, that is going to reduce the soil fertility, and it will alter microbial population and processes. It can modify carbon mineralization and malus nitrogen transformation will be there. Then there will be some indirect problems also due to these metal contaminations in the compost material, like uh, contaminations in crops will be there, because crops are going to take the nutrients from soil, and if the content of if some metallic content is higher in the soil, okay, that are going to get absorbed during the nutrient absorbing process of the plants and crops, and these metal contents are going to contaminate those crops sometimes. Okay, then there will be water pollution, like if some fluoride content, higher fluoride content, or some higher amount of heavy metals is present in the compost material. So those heavy metals or some sulfur, if some higher sulfur content is there, those metals are going to get react with the water, and that will pollute the water body, that will pollute the groundwater body. Okay, so that is indirectly going to create the water pollution. Then there can be air pollution also due to the metal content is in these compost materials. Then coming to pathogens contains in compost, the presence of coliform bacteria is often used as an indicator of overall sanitary quality of the compost. Then Salmonella species were regarded as a problem of the hygienic quality. So that there are some recommended feed coliform and fecal spectroscopic densities for the proper compost hygienation. That is around 5 into 10 to the power 2 mpn per gram. While in the fecal streptoscopy, it has to be around 5 into 10 to the power 3 mpn per gram. Then coming to the phytotoxicity is one of the most important criteria for evaluating the suitability of compost for agricultural purposes, and to avoid environmental risk before these compost can be recycled back to agricultural land. So that has to be on the uh, optimum level, otherwise it is going to uh, create some pollutions in our sand, in the sand. Okay. Then for checking the phytotoxicity in these compost material, we have to do some different types of lab testings. And what is the solution if compost made is not good and metal content is high? Okay. So some corporations add chemical fertilizers in order to increase the quality of compost for proper decomposition of these metallic particles. Okay, then to lower down the metal concentration, various chelating agents like lime, zeolite, biochar have been used during composting process, because what they are going to do, these lime, zeolite or biochar content are going to get reacted with these metal components, and they are going to create some metal, uh, maybe we can say some metal, sometimes they can create some metal oxides, or sometimes they can create some metal organic compounds. Okay, and those compounds can be easily removed from these compost materials. So after the removal of these metals from the compost, that compost can be used as a agricultural compost material. Then there are some status of national guidelines for different composition checks. These are just some rules and regulations regarding the composting materials, like for fertilizer. According to Fertilizer Control Order of India, for composting process, we have to maintain a moisture in the final compost material. We have to maintain a moisture content of around 15 to 25%. pH value should be in between 6.5 to 7.5. Electric conductivity should be lower than 4.0. Then should be total nitrogen percentage has to be minimum than 0.5%. Then phosphorus content should be minimum than 0.5, potassium 1%, carbon to nitrogen ratio 20. Then similarly for vermicomposting process, uh, there are some different parameters for vermicomposting process also, according to the Fertilizer Control Order of India, that has to be maintained before using any compost material for application purposes. Then these are according to fertilizer control order. We can check the 1 second. Okay. Okay. So these tests can be done according. These different testings can be done according to the fertilizer order control order of India. But these tests has to be done uh, in the laboratories. Okay. But how we are going to check the quality of the compost material if we are a layman? Okay. For some basic physical like some testings which we can do with bare hands, and those testings are not going to need any laboratory testings. Okay, so that can be checked according to these parameters. Like bad compost will contain some foul smell. That will The foul smell, generally foul smell in any compost material indicates the presence of some toxic compounds, and mostly it is due to the presence of ammonia content which has not decomposed during the composition process. Okay, for proper composting process, that ammonia has to be fully decomposed into the nitrogen and hydrogen content. Okay, then if you are going to squeeze that compost material, okay, and if there is some draining of water from that compost material, it means the compost is still immature and it needs some more time for achieving the proper maturity or achieving the proper moisture content of around 15 to 25%. Then for if that compost is good, so proper texture and color will be there. Okay, then no foul smell will be there. Then there should not be any smell of ammonia. Appropriate moisture content, it should not be sticky or greasy. And then color should be a dark brownish color, indicates mature and stable compost. Then it should be free from insects and nematodes. Then coming to the last third lecture of the week. So we were talking about composting processes. Now there is one more composting process which is known as vermicomposting. Okay, so vermicomposting is like similar process as we are doing composting, but in the vermicomposting process, as name suggests, it requires some worm. Okay, and those worms are generally the earthworms. Okay, so what these earthworms will do, these earthworms will eat that compost, eat the solid waste material, and they will decompose that solid waste material and converting it into the vermicompost. So vermicompost is the product of decomposition process using various species of worms. Usually, these are red wigglers, white worms, and other earthworms to create a mixture of decomposing vegetable or food waste or bedding material and vermicast. So vermicast, also called worm castings, worm humus or worm manure or worm feces, is the end product of the breakdown of organic matter by earthworms. Then vermicompost contains water-soluble nutrients and is an excellent nutrient-rich organic fertilizer and soil conditioner. If we compare the vermicompost or compost material, okay, so the vermicompost material will always show better properties for the soil. Okay, so these vermicomposting can be done in pit, or maybe in some vessel. It is like similar process as we are doing the composting process. Just one more thing we have to add. We have to add some earthworms in these pits for the proper vermicomposting process. So the mechanism of vermicomposting is like we are providing some biodegradable materials and we are going to mix it homogeneously, and then with the help of and then we are providing some warm earthworms and some oxygen or water content in that homogeneous mixture, and with the help of these three things the vermicomposting process will happen via, and this municipal solid waste whatever we have provided, it is going to decompose into the nitrogen, NH3 and CO2, leaving behind the compost material in the form of organic hydrocarbons. And we can again with the help of during this vermicomposting process we can also harvest some earthworms and cocoons for again creating the warm biomass. Then vermicompost with living cultured soil microbes will be leave behind. Then there are some different types of worms which is generally used during these vermicomposting processes, like NSE. Then it build permanent burrows in the deep soil. Each vermicompost worm has a different work to do during the vermicomposting process. Okay, each possesses different properties. So any NACA will build permanent burrows in the deep soil and drag down their food from soil surface to their burrow and used as bait for fishing purpose. Then endozoic build burrows on upper layer of soil. It will feed on organic matter and mostly visible in rainy season. Then there is epizoic this feeds on decaying organic matter and do not form burrows. Then it is useful for vermicomposting process. And biology of earthworm species suitable for there are some different biologies of earthworm which are suitable for vermicomposting process, and their lifetime period, how much time it is going to create these worms, and what are the different requirements to create these earthworms. Okay, then there are biology of earthworms species suitable for composting. Then there are some basic requirements during the process of vermicomposting which needs to be kept in consideration, like suitable bedding should be there. We have to provide food source for the worms. Then adequate moisture amount should be there. That moisture amount should be around 60 to 70% for in the solid waste material for the proper vermicomposting process. Then adequate aeration should be there. Suitable temperature around 40 to 50 degrees Celsius. Then suitable pH range of around 5.5 to 7.5. So coming to the bedding is any material that provides a relatively stable habitat to these worms. That should have high absorbency as worms breathe through skin. So the bedding must be able to absorb and retain adequate water content. Then good bulking potential. The bulking potential of the material should be such that worms get oxygen properly, and the bedding material should have low nitrogen content and high carbon nitrogen ratio. So high protein content will be provided. So high protein on nitrogen levels can result in rapid degradation, and associated heating may be fatal to worms, because if the temperature is going to be higher at around 60 to 70 degrees Celsius, so worms are not going to sustain at that particular temperature. So we need lower temperature, and sustaining that lower temperature, we don't need very high protein content in these solid waste material or bad material. Okay, because due to these high nitrogen content, what will happen? These nitrogen are going to uh, going will go into the rapid degradation process for forming ammonia and CO2 gases or H2O gases, and that will result in the increase of temperature very rapidly. So we need a bedding material which possesses low nitrogen content. Then some common bedding materials are horse manure, peat moss, straw, wheat, and there are some different properties of these common bedding materials like adsorbency, bulking potential, and CY/N ratio. Then coming to the food source for these worms, we have to provide regular input of feed materials for the earthworms is most essential step in during the vermicomposting process. Earthworms can use a wide variety of organic materials as food, but do exhibit food preferences. Okay, although we can provide any type of organic material, but they have some food preferences. So we have to keep these food preferences in the mind during these vermicomposting process. Then under ideal conditions, worms can consume amount of food higher than their body weights. The general rule of thumb is consumption of food weighing half of their body weight per day. So the if the weight of the worm is around 1 gram or 5 grams, so they are going to consume around 0.5 to 2.5 gram of the food material per day according to their body weight. In adverse conditions, earthworms can extract sufficient nourishment from soil to survive. Okay, then moisture content. The most important requirement of earthworms is adequate moisture. They require moisture content in the range of around 60 to 70%. So if we are going to compare this vermicompost moisture content of vermicomposting process and normal composting process. So in normal composting process, we were going with an I think we were going with a moisture content of around 50 to 60%. While here we have a larger moisture requirement as compared to the composting process. We have a moisture requirement of around 60 to 70% during the vermicomposting process. The feed stock should not be too wet, otherwise it may create anaerobic conditions which may be fatal to earthworms. However, we need a moisture in the range of around 60 to 70% only. If the moisture content is going to be higher than this 70%, okay, so what will happen? There will be not proper aeration inside the waste material during the composting process, and that will result in the anaerobic conditions and resulting in anaerobic digestion process which may be fatal to the earthworms, because during the anaerobic digestion process the ammonia gas will get released, resulting in increasing the temperature of the vermicomposting process. And if the temperature is going to be increased, so earthworms, that will be fatal to the life of the earthworms. Then aeration content factors such as high levels of fatty or oil substances in the feed stock or excessive moisture content combined with poor aeration may render anaerobic conditions in vermicomposting process. And we have already discussed about the what will happen if the anaerobic conditions are going to be created during the vermicomposting process. Then worms suffer severe mortality partly because they are deprived of oxygen and partly because of toxic substances like ammonia produced under such conditions. Then coming to the temperature, the activity, metabolism, growth, respiration, and reproduction of earthworms are greatly influenced by the temperature. And a optimal temperature of around 16 to 25 degrees Celsius is required for the proper vermicomposting process and to for the survival of these worms. The temperature above 40 degrees Celsius can kill these worms, which will affect the vermicomposting process directly. Then coming to the pH, worms can survive in a pH range of 5 to 9, but a range of 7.5 to 8 is considered to be the optimum. And in general, the pH of worms beds tends to drop every time due to the fragmentation of organic matter under series of chemical reactions. So we have to maintain that pH value during the whole process. Then there are some other important parameters also, like pre-composting of organic waste. It is established then that pre-composting of organic waste is very essential to avoid the mortality of worms. Then salt content, that should not be more than 0.5% in the feed. And then urine content, excessive urine, what will happen? Excessive urine will result in the ammonia formation, and due to that ammonia formation, the earthworms are not going to survive for a longer time period. Then other toxic components, like different feeds can contain a wide variety of potentially toxic components. Some of the more notable are like we have to limit the sulfur content during the these composting processes, because that is going to be fatal during the vermicomposting process, because sulfur will react with the oxygen content, creating the SO2 oxide, and that will increase the acidity of the whole process, and that will be fatal to the lives of the worms during the processing. And for the survival of worms, we have to build a worm home. Worm needs air to survive. They can live in a plastic bin or a wooden box with several air holes punched or drilled all around. It is more convenient to have several smaller, more portable units rather than one large one. Then do not use a bin that was once used to store chemicals such as pesticides, or you may end up with a pile of dead worms. Then vermicomposting containers box should be shallow and wider than it is tall for the proper aeration process. An average size vermicomposting bin for a household of 2 people should be 30 centimeter to 40 centimeter deep and 60 centimeter long. Then vermicompost. There are different types of vermicomposting systems. Like it can be windrows, ways, beds, or continuous flow through reactors. Uh, then vermicomposting process can be divided into three different scales, like large scales, uh, creating 250 kgs per week of vermicompost. Then medium scale, which can sustain, which can create which can handle 250 to 20 kg per week, and small scale, which can handle lower than 20 kg per week of composting system. So large scale, in case of large scale processes, we have to go for windrow types vermicomposting system, while in the medium scale we can go with the continuous flow, like batch type, like batch reactors, or maybe we can go for the reactors like we had talked about some rotary reactors, rotary drum reactors. We can go with the those rotary drum reactors type in the medium scale, while in batch small scale we can go with some tray staking or batching or batch type reactors, so that will be helpful. So there are location of warm winds. Warm winds can be located in a number of places, such as the kitchen, basement, or backyards. It is important to allow air to circulate through the bin by leaving the air holes uncovered, because that will help the worms to sustain. If we are not providing proper aeration, so if you are not providing proper aeration system for the circulation of the, then feeding worms, worm food, advantage are some advantage and disadvantages are there. Like labor and equipment cost should be minimal. One of the promising decentralized composting technology. Then some of the disadvantages of vermicomposting systems are initial cost of these systems are very high, and care for survival is very sensitive. Then okay, so these are the lectures. Then we will go with